in this?
370.
In dimes.
In dimes and quarters, so that tells us in both.
5 more quarters in dimes.
5 more quarters in dimes.
Let G be the number of dimes.
Determine how many dimes are series.
Okay. Anyone have a guess as to what one of the equations might be?
5q plus b equals 3.7.
That is a good guess, but no. Abby?
0.1d plus 0.25q equals 3.7.
That is one of them. Go ahead, Abby.
5 plus d equals q.
5 plus d equals q.
That was right.
Okay, so this sentence in yellow, 5 more quarters than dimes, means if I knew the number of dimes and I added 5 to it, I would get the number of quarters. You have to reword that and think about that in your mind. Do we need to solve one of the equations for a variable?
No.
No, because we have one already. What do we do with this? Where?
The Q.
Into the q in the first.
Into the other q. So 0.25 times 5 plus d plus 0.1 d equals 3.7. 3.7. Okay, then what? Distribute. Distribute. 0.25 times 5, what is that? 1.25 plus 0.25d plus 0.1d equals 3.7 or 3.70. And then combine like terms. When we combine these two, how many d's do we have? 0.35. Okay, then subtract 1.25 on both sides. What is 3.7 minus 1.25?
She said it was 10:30. I mean, it's 1:30.
255.
255.
255.
You're answering your question. You're close.
You see with your eye.
45.
No.
No.
What is that?
It's a worm.
And then when we divide, what is the
7.
7? So if D is 7 and Q is 5 plus D, what is Q? 12. Right? There is one, because we started late in this, there's one left in this that we did not do, but we're not going to do. I'm not going to sign it for homework, but I would say to do it for practice. The first one I think we didn't do. Can you not make that up? Thank you. I do want to say this. So today we are going to talk about the last way to solve systems, elimination. Next class, Thursday, we are going to review for our test on Monday. I know, it's on Monday.
It's
We're
been
going
a
to
week,
review
not even.
for some, and then we'll test.
Can we push it to Wednesday?
No.
Friday.
This Friday?
No,
It's even
next
earlier.
Friday.
We're not even in.
Oh yeah, that's what
Right, before we do anything, I want you to write this somewhere on your paper. Add, / subtract, or multiply a common factor add slash subtract to eliminate a variable.
Zara, you should be right. We multiply,
Common factor. So somewhere on that page, write that. As you finish, I'm going to fill these in so you can start filling yours in
Is
as
that-
well.
is that another add and subtract?
Add and subtract to eliminate a variable. So this says make sure equations are lined up. Add or subtract equations to eliminate the variable with common coefficients.
Does that say a common factor?
Yes.
Did you see or multiply?
A common factor and add.
Or multiply. Yes. Coefficient. Solve the equation for the remaining variable. Substitute your answer into either original equation and solve for the other variable. That should seem a little familiar because a lot of those are what the substitution method said. But it is different. This sentence down here kind of goes along with what's written. If there aren't common coefficients, multiply one or both equations by a number to make them common. So, in general, to solve these, we're either adding our equations together, subtracting them together, or if we can't do that at first, we're going to multiply one or both equations by some number so that we could add or subtract. We're going to do the following problems together, so go ahead and start circling this as people are finishing. 1, 2, 5, circling numbers on the next page. 7 through 10,
Hold on, there's 1, 2,
1,
5,
2.
7.
She said 2. Didn't you say 2?
No.
Yes, you did. You said 1, 2,
Uh-huh.
5, 7,
2, 5,
7.
8, 9.
7 through 10, and 15.
Yeah.
To the words.
Wait, what is this?
No, of course that's not what it is, and we got a problem.
Christina.
Alright, so for this, first we need to make sure that our equations are lined up. So what I mean by that is everything in the same place as the other? Are the y's in the same place on both equations? Are the x's in the same place in both equations? Are they constants? Yes, in this one they are. So we don't need to fix anything. If they were not in the same places, we would need to do that first. But they are, so we're okay. The next thing that we're looking at is, do we have a variable, either x or y, that has the same coefficient?
Yes.
Which one?
Oh no, I'm saying it. I'm sorry.
Coefficient is the number in front of your
No.
variable.
Wait, what?
The y. The y's have the same coefficient.
Oh, this whole
So anytime we have something with the same coefficient, we are going to eliminate them. So in the real world, what does it mean to eliminate something?
Well, wait.
Value.
To take away.
To take away, to get rid of.
Yeah.
So in this, when we eliminate our y's, what's going to happen?
We're gonna take it away.
We're
Oh
going
my
to get
god,
rid
I
of it.
am mastermind.
No, you're not.
Now, because we are trying to get rid of our y's, we need to either add or subtract these equations together. Why'd you say subtract?
Because they're both positive.
Okay. So you have to think about that. Could we add or subtract the equations together to get rid of? And which one makes more sense? If we added these together, we'd get 2y, not 0. We want to get rid of it, not get more of it. So if we subtract this equation, we're really subtracting the entire thing. We're subtracting the entire equation.
Wait, so since the y's are equal, but they're both positive, we're subtracting. Alright, that makes sense.
Okay.
So when we are subtracting this, at first take this step by step so you don't miss anything. Y minus y is what? 0. 3x minus x.
It's X.
That's 2x is 2x. And then 4 minus negative 2. 4 what? 4 minus negative 2. 6. So now we need to solve this for x. Y has been eliminated. The only way to really solve this for x is to move 6 to the other side. What is x? Negative 3.
Wait, how is it negative?
We have to move 6 to the other side.
Oh.
So 6 becomes negative and 6 moves. Oh, yeah.
But it's not how you find y.
Okay. Now to find y, we're going to put this back into one of the original equations. Does not matter which one. Yes.
Huh?
I'm going to pick this equation. It does not matter if you pick the other one. It'd be okay. What is y? Negative 5. Remember, these have to be solutions, so you're writing them as ordered pairs.
X into one of those.
Correct.
I don't get it.
So negative 3, negative 5 is your answer.
Wait. How'd you get rid of the 3 then? Oh wait, no you didn't.
Come on, Adam.
So many
You got this.
Look,
What 6?
I look stupid.
Whoa!
That's a.
That's a
Unacceptable
big word you there. Gee.
Whoa, she don't have unacceptable words.
Why didn't she get told anything? If it was me, it would be like.
She was talking about herself, but what did she say?
Did you figure it out?
She said the S word.
Excuse me?
She said it out loud.
I heard her. I'm not deaf.
Yeah, that she's not.
Well, clearly.
Are you writing this down? Do we have other questions?
I don't get it.
What part? Drawing while we're doing this probably isn't helping.
No, I did that, but like.
Come on, Samara. Get together.
You ain't even got it written down.
Said who?
As substitution, you mean?
Yeah.
Not quite. We're not substituting an equation back into the other one. We substituted a number. So that part is the same. The beginning part is not. We're going to do some more. So see if that answers your question.
I thought you only have one y. Why is it y minus 3 minus 2 and then y equals minus 5? Oh, because it's 2 y's. Never mind. I see. I saw.
Do we have other questions right now?
Where'd you get the 0 from? And the 0 equals 2x minus 6. I'm plus 6.
Y minus y is
0.
right. For number 2, do we have a variable with the same coefficient?
X.
X.
Hey, I got it right.
Do you want
Could we add these two together to eliminate them?
No.
No, we would need to subtract. We will not always subtract, so don't assume that.
When can you
Well,
add?
We will do some examples where we have, so relax. Yes.
Have you know subtracting?
Whatever variable you're trying to get rid of, do that. Add them together. Would you get 0?
So,
Wait,
Hold on
so
1 second.
If it's
Add
a
them
positive,
together,
you
would you get
subtract.
0?
If it's a negative, you
No.
add.
wait, so you want to get 0?
Don't assume that. You want to get 0 for one of the variables.
Okay.
So there could be negative variables.
There could be negative coefficients.
So if they're both positives, or is it going to be negative?
Subtraction. You're always going to subtract.
so you don't even have to like try and like get x by itself or anything. You just subtract the equation.
Right, because that's substitution or graphing, and we're not doing that.
But like, if it's on the opposite side, then we have to do that.
On the opposite side,
So like x will be on like the left side of the equation, x the other x is on the right side.
if they're not lined up,
Alright.
then yes. I don't know about that.
Oh, are we doing this?
So the-
No, I just paused for 2 seconds.
So is it true that if you don't like algebra 1, you'll like geometry, and if you like algebra 1, then you won't like geometry?
But if you don't like math, you don't like math. If you do.
Kobe.
What if you like 10 equals 2x plus 5y?
For number 2.
I'm not
messing with you. Wait, say that one more time.
10 equals 2x plus 5y.
It would be 10 equals 5y, but it wouldn't be 2x. If we're subtracting x minus x is what?
Oh,
0. 4y minus negative y. 5. 13 minus 3 is 10.
You got 5 doing what?
4y minus negative y.
Why are you going like up and down?
We are subtracting this equation from this equation.
So,
I said that backwards. We're subtracting the equations together. This 0 is not needed.
You said it's not.
The 0 is not needed. What is y? 2. We're going to put this back into one of the equations. It does not matter which one. I'm going to put this into the bottom.
What is that? Oh.
Putting
Oh, I
y
see.
into the equation. You need to put this into the
Kobe's
equation.
I believe in you, Kobe. You got this.
I need you guys to raise hands. If you have a question, raise your hand. Otherwise, I shouldn't hear your voice. Raise your hand. Raise your hand. Yes. No.
Right here.
It's 5.
Oh, I got that. I knew it.
Why did you add them?
Add 1.
2 and 3? How'd you get to 5?
Add 2.
So like,
It's
what's
not
the
why you add.
why did you add it?
Solve for x. How would you solve for x?
Add it, Christina.
Christina, so you have to bring it to the other side because x is by itself. So then you bring 3 plus 2, which equals 5.
You have to add it.
And then
Always?
Okay, sorry,
Oh,
but
for
how
this
did you
equation,
get
we have that.
y equals 2?
Divide. 10 by 5. 0.
Does it matter if we, like, whenever we're, like, putting it into, like, its final format, does it matter if we put x or y first?
Yes.
So, like to end? Yes. Ordered pairs are x, y.
I was just wondering if you did it.
Ordered. Oh, because I did. Yes.
I was just curious.
It does matter, and I wrote it wrong. Yes.
So first, whatever your answer is. Okay, I got that part. That's it. What's going on?
Any other questions right now? For number 5.
Oh, I got one.
There's a negative.
So there's two x's on the same side and two y's. So how do
Whoa.
For number 2, you're talking
Yeah,
about?
since they're both on the same side.
No, it does not matter, but we were looking for a variable with the same coefficient. And
Okay.
only one of them had that in this case.
Okay.
For number 5, is everything lined up?
Yeah.
No. The x is where the other x should be, but the y is not. We need to move that y before we do anything else. So that's substitution or graphing, not elimination.
Whoa.
So we need to get y on the same side so that it's lined up. Now, do we have a variable with the same coefficient?
Y.
The y's. Could we add these two together and they eliminate or cancel?
No. No. That'd be 6.
No, it'd be -6.
Oh, yeah. Wait.
-3 plus a negative
why would
is
it
just
be
-3 minus 3. So we could subtract in this case. Now, notice that I switched the order of these. It's okay that I did that to them. It doesn't really matter how you add or subtract the equations, whether one was on top or if it's on the bottom now. It does not matter.
So why is that negative?
We're subtracting.
Because I said so.
Wait, how'd you get that equation?
You move 3. Why?
And if it's a positive, you have to make it to a negative. It's new.
It depends, because you may not have to move it at all. In this case, we've had to because it wasn't lined up.
Okay, but when you do have to move it, if it's negative, you would switch it to a positive.
What do you mean it isn't lined up?
Okay.
You see how it says x equals 3y, and the other one says 2x minus 3y? The x's and y's aren't on the same side for both.
Oh, like
They're not lined up.
side? Equal sign.
2x minus negative x
Is
3x. Negative 3y minus negative 3y, 0. 10 minus 11,
I mean, -1.
negative 1. The 0 is not needed. And this one is going to give you fractions or decimals, and that's okay. That will happen sometimes.
If there's a negative outside and then inside, it's a positive, right? Negative. For the beginning of number 5.
You add. Leave it as a fraction. Okay. Now, we can either put this back into the original 2 or the one we changed. It does not matter as long as you solve it. I was going to choose for you for this one anyway. We're going to put this one into this first one. I'm going to do it in 4's box because I don't really have room.
So it becomes -1/3.
Would it be positive one third?
It would become positive 1/3.
So you why is it so negative?
I just put it in. I haven't done anything yet. This would become 1/3. How would we solve for y?
You have to move.
Move what? 11? Move 11 how?
By making it a negative.
By subtracting. So in your calculator, do 1/3 minus 11 in fractions. Alpha y equals.
-32/3.
And then to get rid of 3, we need to either divide by 3 on both sides, but then we have fractions within fractions. So instead, let's multiply both sides by 1/3. Multiplying by 1/3 is the same thing as dividing by 3. So y would equal negative 32 over 9. So your ordered pair would be negative 1/3, negative 32 over 9. In order for this to work, the coordinates of whatever it's called, this variable have to be like both fractions. In order for what to work? The solution? Yeah. In order for this solution to work, it has to work for both equations. So we would just have to put both of those in and they would work for both. Okay. Do we have other questions on 5 before we move on? For 7, do we have a variable with the same coefficient?
Yes.
Yes. What?
Isn't it X?
Yes.
It is x and y, but pick one for this case. X. Okay. Would we add or subtract to get rid of x? Subtract. 3x minus 3x is 0. Negative 4y minus negative 4y also 0. Negative 10 minus negative 13. Positive 3. So this is really 0 equals 3. What does that mean?
Undefined.
Not undefined. 0 is not the answer.
What other words are
Does 0 equal 3?
No.
Oh,
So,
wait. Oh, it's a slope.
No solution.
Yeah, wake up.
Hey.
Good morning.
That means no matter what numbers you put in for x and for y, they will not work at all. Ever.
I see.
For 8, do we have a variable with the same coefficient?
No.
So they both have the same number, 2 and 2, 1 and 1, except one is positive, one is negative. That does not matter.
Okay.
Yes.
So yes, we have 2. But for our purposes, let's just pick one.
X.
Okay. How would we get rid of
We know
these
why.
x's? It doesn't matter.
You would, you do that thing.
Could we add these two?
Wait. Subtract this.
If we subtract 2 minus negative 2, would that get rid of the x's?
No.
We have to add. So 2x plus a negative. 2x plus negative 2x is 0. Y plus negative y. 0 also. Negative 10 plus positive 10. 0. So really we have 0 equals 0 on the
Infinite.
in infinitely many solutions.
What?
0. What does that IMS mean?
Infinitely many solutions, yes.
Ow.
That's a negative 2.
So in this case, really in all cases, the number has to be the same. It doesn't matter if they're both positive, both negative, one's positive, one's negative. It doesn't matter because you end up adding and subtracting anyway.
Yes.
For number 9, do we have a variable with the same coefficient?
Yes.
No, we don't. So anytime you don't have one, you need to make one. So how you make one is first you need to choose whether you want to eliminate your x's or your y's. Okay. And then we need these both to have the same number. That means we need to multiply this by some number so that it's the same. What number would that be? 2. Now you can multiply it by -2, and that would still work. 2 or -2, does not matter. But what you do to one thing, you have to do to all, so you're really multiplying the entire equation by 2.
So 6y.
So I'm going to rewrite that down here. 12. Now if we're trying to get rid of our x's, what would we do to get rid of them? So 0, -7y minus 6y. -13y. -1 minus 12.
That's 13.
-13 also.
I said
So if you need to, use your calculator. 0 is not necessary.
Give me my spark guy.
What is y? 1. Positive 1. And now we can put that back into any of these. Either one of the originals or the new one. Which one do we want to put it back into? Original. Which one?
This one, bro, my P gave it to me.
New.
top.
Okay.
He's chilling.
Alright, so now put 1 in. Put 1 in here. So x plus 3 times 1 equals 6. X plus 3 equals 6. What does x equal? 3.
Just like my jump.
Okay. So 3, 1 is our answer.
Give me mine.
Do we have questions on 9? Yes, Julia. After some more. Do we have questions on 9?
I'm straight.
No.
Don't say it.
Where'd the time go?
Bruh, MJ loves talking about me.
120. I'm not talking about you.
You looked at me. Didn't you comment what I said? Didn't you comment about what I said?
I was like,
I don't know what
it
you said.
should
What are
be
you talking about? I'm talking about.
This is all we're doing.
You guys are gonna have.
You must love me.
Alright, for number 10, do we have a variable with the same coefficient?
No.
No. Do we want to solve for x or for y?
X.
Okay. Now, in this case, it wasn't like we have just one variable that was a single digit. We have 2 with 2 different coefficients. That means we need to multiply both equations by some different number that are common multiples.
we can multiply 3 by 5 and 5 by 3.
Yeah.
You multiply your top by 5 and your bottom by 3.
Wait, why are you doing that?
You need to get the same number, so you need to get common multiples. 15 is the lowest common multiple between 3 and 5.
This is
Why
like
does
some
it have to be the
fractions.
lowest?
It doesn't matter.
It doesn't have to be the lowest, but if you go higher, you're going to have big numbers. So it doesn't have to be the lowest, but also, you could have made one of these negative, but you don't have to. That's completely up to you. So 15x plus 15y equals 45. 15x plus 12y equals 30. How would we get rid of our x's?
By subtracting them.
By subtracting.
I'm smart, Mr.
Are you?
Stop.
I just don't
And a
try as much.
That is true. That is
Uplift each other.
apologize.
Sorry, John.
It's cool. Right, Mr. Arnold? I'm smart, I just don't try, right?
Yes.
Agreed. You should try, Josh.
15y minus 12y. 3. 45 minus 30. 15. 0 is not really needed. So what is y? 5. Now you have 4 different options to find x.
Is that a y? On 30.
Yes. You can put it in one of the originals, or you can put it in one of the new equations. It does not matter. Which one?
The top.
Okay.
First one.
I'm going to put this over here. So we're going to put 5 in for y here. So 15x plus 15 times 5 equals 45. What's 15 times 5?
Oh, I'm supposed to do that. 15 times 5. 75.
75. And then if we subtract 45 minus 75 is... Wait. 45 minus 75,
I just saw the second one and I got
negative
mad.
30. Okay. What is x? What's x? Negative 2. So our solution is negative 2, 5. Yes.
Donald Trump is the best.
Wow,
Oh
I'm
my
gonna
God.
do it.
Can I do this?
No,
So,
I cannot hear Sierra's question.
with, like, whenever we're checking to see, like, whatever the number is, like, let's just say for x, can we plug in x with, like, any place where there's an x? Like, at all? Like, even if it's, like, all the way in our equation?
Like here, could you put this in for either x?
Yeah, like, anywhere there's an x times 2.
Yes. Alright, for 15. What is our first step for 15?
To find the variable. Yeah.
The variable with the same coefficient. Do we have that? No. We don't have a variable with the same coefficient. What would be the next step?
To multiply.
Okay, to make sure there is one, we need to multiply. So what are we solving for?
X.
Okay, so what are we multiplying by? Negative 5 and 4. So in this case, 5 and 4, yes. We don't need to multiply by a negative in this case because we already have one. And you can, and you'll end up with the same things. So multiply 5 to the top and 4 to the bottom. Distribute 20x minus 8y equals 25. Negative 20x plus 12y. Yes. I'm sorry. 10y equals negative 4. I made that same mistake in 4th period, and no one caught it till the end. Okay. How would we combine these x's?
You
Add.
In this case, we need to add them.
I just said subtract because I thought.
We don't have a Nathan in this class.
So, in this case, if we were to subtract 20 minus a negative, we would end up with negative 10
I like how
plus
I'm with
12.
sophomores in this class.
Is
No.
Be positive 2.
Bring it to you.
25 plus a negative 4.
No.
25 plus a negative 4.
No, te va a quedar ahí, lo vas a chingar. Te vas a dejar ahí que...
Stop talking.
Stop talking.
I'm sorry, what?
Wait.
How did you make it?
Because you had to multiply by 5.
So you had a negative, yours going to be a little different.
That's what you be doing.
You should end up with the same answer. What is y? 21 over 2 or 10.5. So now we're going to use this and put it back into one of these equations. Which one do we want to put this back into?
The first one.
Yes.
How about we try the bottom one?
How about
You go ahead. You're going to get the same thing. It doesn't matter.
What did I say? Orlos?
What?
10.5.
Oh.
Wow.
Oh!
What is 10.5 times negative 2? Negative 21.
No. Because lo vas a dejar ahí, that's why.
5 or 2.
6.5.
Can never see me happy, I swear.
When we add, we get 26.
Wait, yes, Miss Thorpe. That's
Are you asking a question about this?
Yes.
It says 21, 2, or what?
21 over 2.
No,
or,
and then
or 10.5.
Or X.
So 13 over 2 or 6.5.
Wait, how'd you get that cross one?
So much.
Define X.
Like, are you talking about the fraction or the fraction? Divide both ways. So your answers, your solution could be either in fraction form or in decimal form, not both.
13 over
Have you ever gotten this?
Were you high?
whoa, hold on,
On the medicine.
hold on, we don't do that in school.
Were you like, were you like funny after?
You're like,
High on the medicine.
I was.
That's not the correct.
Whoa, we don't talk about that stuff in school.
You sound like everybody else. You just listen.
2, 2, 3, and then we pull up 2 out.
They counting me down, and I woke up.
Miss Thorpe was like, wow, what a nice snap.
no, you asked that question.
Teacher, comment down.
Eyes and ears back up here.
Oh, snap.
You have the rest of class to finish those examples. I will be passing out a homework sheet.
Bro, you're sweet.
Listen,
Be quiet.
listen. When I pass out that homework sheet,